Okay, so what we're going to be dealing with today is transitional ionic compounds. So if we take a look at transitional ionic compounds, hopefully you have watched binary compounds and polyatomic compounds videos prior to this, so that some of the stuff we're talking about will make a little bit more sense. If not, follow along the best that you can. So let's take a look now at transitional metals. So we take a look here. Groups 3 through 12 are transitional metals. You'll notice that no oxidation numbers are written above them. Why? Because they're crazy. All right, they have multiple personalities. They don't know what they are. Whereas, group 2, all these elements are always going to be a +2 every single time. Where the transitional metals aren't the case. They can have different oxidation numbers depending. So, because of that, they need an ID badge. All right, and we're going to use Roman numbers to represent their oxidation numbers. So let's take a look at writing chemical formulas first. All right, the steps are real easy. Just like before, we're going to write the chemical element symbol. We're going to write down the oxidation number. Now remember, for the transitional metals, it's going to be the Roman number. And then we're going to crisscross. So let's take a look at what that looks like. So iron 2 fluoride is the compound we're dealing with. So we take a look and write the symbols down. Fe for iron, F for fluorine. We write down the oxidation number. So remember, the Roman number 2 here is going to be the oxidation number for iron. So therefore, it's going to be Fe plus 2. Fluorine is in group 17, so it's a -1 charge. And then we're going to crisscross. So the superscript becomes the subscript for the opposite element. So 2 comes down, 1 comes down. We end up having an answer of FeF2 for a chemical formula. Pretty straightforward, just like we've done before. The only difference, remember now, is the Roman number gives us the oxidation number, whereas before the periodic table did. Now, what about naming? Naming, pretty easy too. A little bit of a tweak, but here are the steps. Let's take a look. So the first step is to write down the first element's name. So second one, write down the second element's name. The third step is to, at that second element, we're going to drop the ending and add IDE to it, just like we did before. Or if it's a polyatomic ion, then we're going to check the chart and simply write down what it says there. Step 4 now is we're going to reverse crisscross to find that Roman number. That's the big difference here. So let's take a look and see what that looks like. So here we have Fe3P2. So go take a look at the first element here. Fe, found in the periodic table, is iron. Okay, it's a transitional metal, so we're going to probably need parentheses. We're going to take a look at the second element now, and that's phosphorus. We change phosphorus, drop the ending, and add IDE. And now the fourth step is to reverse crisscross. So we're going to take off to the right-hand side here in the blue. We have this 2. We reverse crisscross. It comes up, and that's going to be the oxidation number for iron. Remember, the oxidation number is going to be represented by a Roman number. So we're going to change that 2 into Roman number 2. So our ending answer is iron 2 phosphide. Okay. Well, what about this? Now all of a sudden we've got another example. We have iron once again. So we write down iron. Now we go to the second element. Wait a minute. Oh, CO3. Now we can find C on the periodic table and O on the periodic table, but not CO3. So we're dealing with a polyatomic. As you can see here, we've got the gates showing us that we have got many atoms acting as one. So we're going to take a look at our chart and see what it says. And it says that CO3 is carbonate. So we write down carbonate. Because iron is a transitional metal, we're going to have parentheses, and we're going to have to reverse crisscross. So we go to the last number, the last subscript, and we reverse crisscross it, so that 3 comes up, and it becomes our Roman number. So the final answer here is iron 3 carbonate. Okay? Not a big difference. So we take a look at, let's try one more here. Now we're going to get this a little bit trickier, but the same process still holds true. So we have FEP here. Now we'll notice the big difference here is notice that there are no subscripts written at all. That's a key. So keep that in the back of your head right now. So we write down the first element, iron, right? Because it's a transitional metal, we're going to put in parentheses because we know that Roman numbers are going to be written in there. We go to P on the periodic table, which is phosphorus. So we change phosphorus to phosphide. And now we have to figure out what is the Roman number we're going to have to put in here. Well, if we look here, because there are no numbers written down as subscripts, we have to look at the second element's superscript. Okay? And because we know for sure phosphorus, according to the periodic table, is a -3 charge. Okay, and therefore we know iron has to be a +3 charge because they cancel out, because we have FeP for a chemical formula. So therefore, the +3 and -3 had to cancel out. Well, if they cancel out, that means that iron has a +3 charge, and we write Roman number 3 in. So our final answer is iron, Roman number 3, phosphide. All right, we take here one last example here. So now we have a polyatomic ion involved. So we have FeCO3. So once again, we write down the first element found in the periodic table. Iron is a transitional metal, so we're going to put parentheses down. We then take a look at the periodic table for CO3, which you're not going to find, so we have to go to the ionic chart. We take a look, and CO3 is carbonate, so we simply write down what it says to write down, carbonate, and then we go on to finding out what exactly is the oxidation number. Now, in the past, I've suggested you guys always put parentheses around all your polyatomic ions because it makes it a lot easier to figure out how to come up with a proper name. And this is why. Because normally what a mistake many people will do is they'll think it's iron and they'll think of putting down this 3 right here as the Roman number. But that's not the case. Because remember, polyatomic ions are many atoms acting as one. So what is the last number written down here? Well, in this case, there's a 1. Okay, because there's only one CO3. And because there's no numbers written down here, no subscripts, we go to the top, all right? Because we know CO3 has a -2 charge, and therefore iron has to be a +2 charge because they cancel out. So therefore, our final answer is going to be iron to carbonate. So the rule of thumb that I say is that if there's no numbers written down as subscripts, you go to the top shelf of that last element and write down the superscript as the Roman number, because that superscript has to be identical to the superscript of the transitional metal because they cancel. Hope this helps. Good luck.